Namaste dosto. Imagine you want to tell your friend exactly where you parked your bicycle in a big park. You can't just say somewhere near the trees, right? You need a precise address. In math, we use the Cartesian coordinate system to give a clear address for points on a plane. So, what is this coordinate system? Picture two straight lines crossing at right angles. One horizontal called the x-axis and one vertical called the y-axis. They meet at a special point called the origin, which we call 0, 0. Now, a line on this plane is much more than just a drawing. It's the set of all points that satisfy a special kind of equation involving x and y. Specifically, every point on the line fits into a linear relation. A times x plus b times y plus c equals 0. That is, asterisk ax plus b y plus c equals 0 asterisk, where a, b and c are numbers, but a and b are not both 0. If you pick any point with coordinates x, y that fulfill this equation, that point lies on the line. Think of the line as a collection or locus of all such points. It's like saying, I only live where the rule ax plus b y plus c equals 0 holds true. Now that we understand lines live on the coordinate plane, let's look more closely at their common equation called the general form. The general form is asterisk ax plus b y plus c equals 0 asterisk, where at least one of a or b is not 0. This form is very special because it includes all possible straight lines in 2 dimensions. Whether your line is slanting, horizontal, or even vertical, it fits here. Let's talk about special cases. If a equals 0, then the equation becomes asterisk by plus c equals 0 asterisk, which simplifies into asterisk y equals minus c divided by b star. That means the line is horizontal, running left to right. On the other hand, if b equals 0, you get asterisk ax plus c equals 0 asterisk or asterisk x equals minus c divided by a asterisk, representing a vertical line. From this general form, we can derive other popular forms such as the slope-intercept form, intercept form, and point-slope form, which are often easier to use depending on what information we have. So, the general form is like the master key for all straight lines, accommodating even the vertical and horizontal ones that can be tricky in other forms. The slope-intercept form. If a line has slope m and cuts the y-axis at c, its equation is y equals mx plus c. This comes directly from the general form. If we solve for y when b is not equal to 0, the equation becomes y equals negative over b times x minus c over b. Here, slope m is simply the change in y divided by the change in x. It shows how steep the line is. The y-intercept, c, is the exact point where the line crosses the y-axis. This form is especially useful when we know both the inclination of the line and a point where it meets the y-axis. If a line passes through a point with coordinates x1, y1 and has slope m, then its equation is y minus y1 equals m times open bracket x minus x1 close bracket. This comes directly from the definition of slope between 2 points. M equals y minus y1 divided by x minus x1. This form is especially useful when we are given just one point on the line and its slope. And remember, it can be rearranged into other forms of line equations depending on the information available. Moving forward, what if you have 2 points on the line, but you don't know the slope explicitly? Suppose the points are A with coordinates x1, y1 and B with coordinates x2, y2. The equation for this case is asterisk y minus y1 equals open bracket y2 minus y1 close bracket divided by open bracket x2 minus x1 close bracket times open bracket x minus x1 close bracket star. Say it slowly. Y minus y1 equals parentheses y2 minus y1 divided by x2 minus x1 close parentheses times open bracket x minus x1 close bracket. This comes straight from the definition of slope being rise over run between 2 points. The beauty is that you don't need the slope first. The formula calculates it automatically. Also, You can treat this as the point-slope form once you pick one point and a slope. Now, let's see the intercept form, which is very handy when you know where the line touches the x-axis and y-axis. Suppose your line crosses the x-axis at point A and the y-axis at point B, with both A and B not zero. Then, the equation becomes asterisk x divided by a plus y divided by b equals 1 star. Read it carefully. X over a plus y over b equals 1. This is derived by rewriting the general form so it reflects the intercepts directly. The intercept form shows a beautiful symmetry, creating a triangle formed by the axis and the line, nearly like the slices of that pizza we talked about. This form is perfect for analyzing where the line cuts the axis. So far, all forms relied on points or slopes. But here's a neat geometric perspective: the normal form. This uses the perpendicular distance from the origin to the line. The equation is asterisk x times cosine alpha plus y times sine alpha equals p star. Said slowly, x multiplied by cosine alpha plus y multiplied by sine alpha equals p. Here, asterisk p asterisk is the shortest distance from the origin to the line, and asterisk alpha asterisk is the angle this perpendicular makes with the x-axis. Notice how asterisk cosine squared alpha plus sine squared alpha equals 1 asterisk, confirming the coefficients form a unit vector. This form emphasizes geometry and perpendicularity, highlighting how far the line is from the origin. You can think of this as shining a flashlight from the origin and measuring the shadow's length and tilt. It's a different but insightful way to describe a line. Now, dosto, time for a practical example. Suppose we are given 2 points, A at coordinates 2, 3, and B at coordinates 4, 7. We want the equation of the line passing through both. First, let's compute the slope. M equals, open bracket, 7 minus 3, close bracket, divided by, open bracket, 4 minus 2, close bracket. That is 4 over 2, which equals 2. Say it again clearly. M equals 7 minus 3 over 4 minus 2 equals 2. Next, we use point A, which is 2, 3, in the point-slope form. That gives y minus 3 equals 2 times, open bracket, x minus 2, close bracket. Now expand, y equals to x minus 1. Finally, let's check with point B. If x equals 4, then y equals 2 times 4 minus 1, that is 8 minus 1, which equals 7. Yes, point B lies exactly on the line. Let's quickly recap all the forms of a straight line we covered. First, the slope-intercept form, y equals mx plus c. This is great when you know the slope and the y-intercept. Second, the two-point form, y minus y1 equals, open bracket, y2 minus y1, close bracket, divided by, open bracket, x2 minus x1, close bracket, times, open bracket, x minus x1, close bracket. This form is ideal when you're given 2 points on the line. Third, the intercept form, x over a plus y over b equals 1. Perfect when the x-intercept and y-intercept are known. Remember, each form fits a different situation, depending on whether you know the slope, a point, or the intercepts. And with a little algebra, you can convert one form into another smoothly. Finally, the normal form, x cos alpha plus y sin alpha equals p. This gives valuable geometric insight by emphasizing distance from the origin and the angle of inclination.